For section 6.5, we're going to talk about quadratic equations. So we've got to do some preliminary work before we dive into the actual quadratic equations themselves. But just as a kind of a quick overview, when we were in the previous sections in chapter 6, we were talking about linear equations in one variable. Okay, so a linear equation in one variable means you're going to have one type of variable. Okay, so that means you're going to have like all x's or all y's or all p, whatever. And then all of the variables have to have an exponent of 1. That's what makes it linear. When you start to talk about quadratic equations, the big difference is you're still going to have one type of variable, but the variables can have exponents of 1 or 2. Okay? So that exponent of 2 is what makes a quadratic equation quadratic. Now, as far as what the equations look like, how we solve them, the solutions, the graphs, totally different, but just for right now, that's what you need to know. Linear exponents of 1, quadratic exponents of 2 somewhere, okay? Now, we do need to talk about some new definitions, all right? Prior to this, especially in 6.1, we talked about algebraic expressions. Algebraic expressions, that's a broad term in math for the addition and subtraction of terms, okay? So it's very broad. A type of algebraic expression would be a polynomial, okay? And for us, we don't need to get too deep in the definition of a polynomial, but the difference between a polynomial and just a generic algebraic expression is the type of exponents that we can have on our variables, okay? So they have to be non-negative and um, integer values is kind of how we look at the polynomials. So integers that are non-negative for our exponents. Don't get too bent out of shape about that, okay? Now, generally speaking, for us, a polynomial is it can be a single term or it could be the sum of two or more terms containing variables with whole number exponents, okay? Now, you could also kind of like break this down. There are types of polynomials that show up regularly. For us, we're going to talk about binomials and trinomials, but there's also something called a monomial. So it's a polynomial in a single term. So I don't even want to call it a polynomial. It's just a single term, I'll say, just to keep it kind of short here. So when you have polynomials, again, the big thing is the exponents have to be whole numbers. And if you have just a single term, we would call it a monomial. If you have exactly two terms, we call it a binomial. And if you have exactly three terms, we call it a trinomial. In this worksheet, we're going to talk about binomials and trinomials. Okay? Now, officially topic one. For topic one, we need to know how to multiply binomials using something called the FOIL method, okay? So binomials, remember, they're polynomials that have two terms, okay? So you could have something like 5x plus 1, and then we're multiplying two binomials, so you could have something like 3x minus 7. That would be two binomials, okay? And we can multiply these using the FOIL method, okay? So FOIL is just an acronym, okay? It stands for first, outer, inner, last, okay? So first, outer, inner, last. And what that means is the terms in the two binomials, okay? So FOIL, again, is just an acronym used for multiplying two binomials. And what we're going to do to kind of define this, we're going to look at two binomials. The first one is just A plus B, and the second one is C plus D, okay? So F represents the product of the first terms in each binomial. So if we're looking at the first terms in each binomial, that would be A and C. So that tells us to multiply A and C. Okay. The O represents the outer terms of each binomial. So you have these two binomials sitting side by side. We're looking at the term at the very beginning and the term at the very end. So that would be looking at A and then D. Those are the outer terms. Okay. So we would multiply A and D next. I represents the product of the inner terms of each binomial. So again, we have two binomials sitting side by side. We're looking at the two terms nested in the middle. Okay, so for us, that would be B and C. So that would be the third thing we multiply would be B and C. And then L represents the product of the last terms in each binomial. So of the two binomials, which term comes second? So for us, that would be B and D. So we would multiply B and D last, okay? So you'd multiply the first terms first, the outer term second, the inner terms third, and then the last terms fourth. And then if you need to, you would simplify at the end. So looking at A plus B times C plus D, we would take A times C, we would take A times D, we would take B times C, and then we would take b times d. So essentially what we're doing is we're distributing each term in the first binomial through the second binomial. That's kind of another way to think of it, okay? So let's go ahead and practice. We have 3 examples down here. Example 1 says use the FOIL method to find each product, write the answer in standard form. Standard form just means highest exponent to lowest exponent ending with the constant. Okay, so I'll kind of explain standard form once we get in here. Okay, so for part A, we have x minus 3 times x plus 5. Now we can do that FOIL method. So the first terms would be the x's. The outer terms would be that first x and then the 5. The inner terms would be negative 3 and then the second x. And then the last terms would be negative 3 and 5. Okay. I tend to think of it more as just distributing the first terms or the terms in the first binomial, excuse me, through the second binomial. It ends up being the same thing. Okay. So let's start with this x right here, this first x. We want to distribute it through the second binomial. So I need to take x times x. Well, x times x, that would end up being x squared. We are multiplying two things that have the same base. We keep the base, we add the exponents, okay? I then need to take x times 5. Well, 5 times x is just 5x. All right, so I'm done with the x in the first binomial. I now need to pick up the negative 3 in the first binomial. So I want to take negative 3 times x, so that would be just minus 3x. And then negative 3 times positive 5 would be negative 15. Okay, so we did our first terms, our outer terms, our inner terms, and our last terms. And now we just need to see if we can combine like terms in our products. So we have 4 little products here that are being added and subtracting. The 2 middle ones have like terms. They have matching variable parts, so we could combine. So this is going to be x squared. 5x minus 3x is 2x. And then minus 15. And this is in standard form. We have our highest exponent first, the next exponent in order of, small highest to lowest. I am like stuttering my words. So standard form. We want to put the terms in order based on exponents, highest to lowest, and then end with your constant is what I was trying to spit out. So we have our squared term first, our linear term second, and then our constant third. So that would be our final answer. Okay. For part B, we have 2x minus 9 times 6x plus 1. So I'm going to start with 2x in the first binomial. I've got something in my eye. And then I'm going to distribute that. So I get 2x times 6x. So we're going to take that first term in the first binomial, distribute it through the second binomial. So 2x times 6x is 12x squared. Okay, we multiply the 2 and the 6. We need to multiply x times x. That's multiplying 2 terms with the same base. So we keep the base of x and then we add the exponents. Next, I need to take 2x and multiply it by 1. 1 times 2x is just 2x. Now I'm done with the 2x in the first binomial. I need to take the negative 9 in the first binomial and distribute it through the second. So I take negative 9 times 6x. Well, negative 9 times 6 is negative 54, and then we just keep the x. And then negative 9 times 1 is negative 9. Okay? So let's see, we can combine like terms again. The middle terms are like terms. They have matching variable parts, so they can be combined. So I'm going to just drop down my 12x squared. And then 2x minus 54x is negative 52x. And then drop down the minus 9. And again, this is in standard form. Remember, for us, standard form is highest exponent to lowest exponent, and then end with your constant. So write your terms based on the exponents on the variable, highest to lowest, and then always end with your constant. Okay? One more example of multiplying binomials. I have 3x squared minus 4x times 7x minus 2x. I want to take the 3x squared in the first binomial and distribute it through the second binomial. So 3x squared times 7x. We want to take 3 times 7, which is 21. And then we have x squared times x. That's multiplying 2 terms that have the same base. So we keep the base and we add the exponents. So 2 plus 1 is 3 here. Next, I'm going to take 3x squared times negative 2. So 3 times negative 2 is negative 6, and then just keep the x squared. I'm done with the 3x squared in the first binomial. I now need to pick up the negative 4 in the first binomial and distribute it through the second binomial. So negative 4x times 7x, negative 4 times 7 is negative 28. X times x is x squared. We're multiplying two factors that have the same base. Keep the base, add the exponents, okay? And then I want to pick up negative 4x times negative 2. So negative 4 times negative 2 is positive 8. And then I just want to keep the x, okay? So now we write this in standard form. So looking again at the middle two terms, they happen to be like terms. They have matching variable parts. They both have an x squared, so we can combine those. So I'm first going to drop down 21x to the third. And then I've got negative 6x squared minus 28x squared. So when I subtract those, I get negative 6 minus 28. That's negative 34x squared. And then we end with just plus 8x. And this is in standard form because looking at our variables, we have them in order from highest exponent to lowest exponent. So that is multiplying two binomials using the FOIL method, okay? When we come back, let's see, let's get a peek. We're going to look at factoring. So in math, algebra specifically, there's something called factoring, and it basically is the way we undo multiplying polynomials, okay? So we'll do that in the next video.